Hi, everybody. This is Dr. Schulman. We're starting the second group. Who's excited? So we finally did everything for part one. Hopefully your test went well. You cried on your test. Guess what? Reach out to me. I'm more than happy to help you out. But we get to start on a new group, proportional relationships. I hope you're as excited as I am. This one's only two parts, but I really want to make it good. Um, Students mess up proportions and conversions and ratios and odds and rates all of the time, right? So I'm sharing my screen. And the first thing I want us to do is one, be happy we're finally in a new thing. So hopefully it'll be clear and it won't be as laggy. But the main difference between proportions and ratios, right? A lot of people, a lot of students don't know what the differences are. They're not sure where these differences are. So I'm here in proportional relationships. So there should be two parts. There's A. I don't know why I don't have B here. So here's B. We'll need B at some point. Put it near the bottom. But oh, they're together. So I already had B on there. So I know it's so small. So a lot of people don't understand the difference between a ratio and a proportion, right? What's the difference? Like you might think they're the same thing, but one's like a group and one's like two different groups. Maybe I'll look up a picture to help because a lot of people out there are way smarter than me. So here we go. A ratio is a way of expressing the relative size of two qualities, and a proportion is an equation that says the two ratios are equal. Okay, that's not the best way to describe the differences, but the best way to think about it in my mind is when I think of a ratio, basically, we're talking it's two qualities of the same thing. Two qualities of the same unit. So when they say that, what do they really mean? All they're really talking about is, let's say we're talking wins and losses, right? We're talking games. So it's like 3 wins versus 2 losses, wins, losses, right? So we're talking the same unit. The unit here is a game. Now, what's change this with proportion? A proportion. Now, a proportion is basically if we have two groups that are already equal. So let's say this is our ratio. 3 wins for every 2 losses. 3 wins for every 2 losses. But let's say we played I don't know. Let's say if I get 8 wins, right? Or let's make it really easy. Let's say I have 9 wins, right? I got 9 wins. How many losses does that mean? Well, we can see that the scale factor, we can multiply this by 3. 3 times 3 is 9, or 2 times 3 is 6. So we're going to get 6 losses because 3 halves and 9/6 are the same thing. It's just like this is like two separate groups, right? This one is just like one set, and this is like combining two sets. I think that's the best way you should think about it. Ratio ends with an O. You can think about it as one set. Proportion has two O's. So you can think about it as two sets. That's a way I've always told my students to remember it. Two O's, two sets, one O, one set. The other way you can do it is cross multiply. So every time we have two fractions and an equal sign, I always tell my students that this is like a thorax. And then there's a little antenna coming out, and cross multiply rhymes with butterfly. So 9 times 2 is 18, and 3 times x is 3x. So to get this by itself, all we have to do is divide both sides by 3, and we get, guess what? X is still 6 either way. But notice that there's like only one set for the ratio. That's basically all you kind of have to remember. As long as there's one set for the ratio, you're never going to mess it up. And two sets proportion, it's two groups happening at once. I hope that was clear. We're going to jump into the problems, but uh, really take your time with this with your students to really make sure. If AB is a ratio, then A to B equals C to D is a proportion, where C and D are also qualities of the same unit. It's like we've got two things happening, which makes it a proportion. All right, so let's go to all the problems that I made for this. So we're in 2A. which is proportional relationships. I'm going to edit it so we can look at them all. Here are all the skills, not many. See, like the first one was so long, there's barely any here. But let's jump into these. I'll use this to do them. Here's an introduction to ratios. Ooh, circles versus squares. Find the ratio of circles to squares in the diagram. So I have two circles. Oh, they want unsimplified. So I have two circles. How many squares? 1, 2, 3, 4, 5, 6 squares. Let's see if I did that right. Yes. So for every one circle, there are 3 squares. So the ratio is 1 to 3. Now, it doesn't matter how we set up our ratio. It could be the other way. It could be squares to circles. So instead of circles to square, you just have to stay consistent. Okay? We got it. Since they're identical, you only need to look at the top line. That's a really good way to break it down and make it easier for your students. All right, let's go to number 2. Ooh, level 2, maybe they're harder. Ooh. So now I have 2, 4, 6 squares, because it says squares, but not to triangles. It's squares to total shapes. So we need them all. So ready? 3, 6, 9, 12, 15, 18, 21. Counted them all by threes, because vertically they're in groups of threes. If you go across, it's 7, 14, 21. All right, so for every 2, so we're dividing this by 3. So for every 2, we get how many total shapes? 1, 2, 3, 4, 5, 6, 7. So that is your ratio, 2 to 7. Guess what? We got it. And you could just look at the top line for help. Just notice that it says not squares to triangles, but squares to total shapes. All right, now we get to simplify some basic ratios for us. So if we have 2 triangles and 6 circles, what is the simplest way? So if I have 2 to 6, we know that they're both even, so we can divide them both by 2. We're left with 1 to 3. Nothing too crazy about that. They said total shapes, it'd be 2 to 8 or 1 to 4, but they said just the other shapes. They did the greatest common factor, which is great, and you've seen that before. So if you want to use GCF, guess what? Use your GCF and divide. You want to make pictures, make pictures. All I did was make fractions and divide. Any one of these ways works. So greatest common factors, or so you just look at all the factors, you see the greatest common factors 2, we divide them by 2. Boom, you're done. All right, let's simplify a ratio. That's not basic. Okay, this one looks harder. 35 to 63. Now, knowing what number goes into this one could be kind of tough. Now, the best way I would do to do this, I would have my students make a 20 by 20 multiplication. So it's 1. So it's 1. You start with 0. 0 times 0, 0. Then I'd have 1, 1, 2, all the way down to 20, all the way across to 20. This way, I would know that 3 plus 5 and 6 plus 3, 35 and 63 are both divisible by 7. They're probably going to show the greatest common factor way. So it's 1, 5, 7, 35, 1, 3, 7, 9, 12. I'm pretty sure it's 12 and 63. You'll see 7's the greatest. We can divide them both by 7. It's 5 by 9. That one was tough, but guess what? We got it. Oh, they did the greatest common factor way, 1 and 7. It wasn't 12, it was 21. Oh, see, even I made a mistake with the factors. I need to practice my factors. All right, let's use some ratio language. So all we have to do is fill in the blanks to express the quantities in a ratio. Ratios must be in simplest form. 9th, 10th, 11th, 12th. So for every blank students in 12th grade, there are how many students in 9th grade? So we're going 12th to 9th. And we just have to simplify. So 12th is 21 and 9th is 15. 2 plus 1 is 3. 1 plus 5 is 6. What goes into both of them? They're both divisible by 3. So it's for every 7 kids in 12th grade, 5 kids are in 9th grade. That's how you do this one. I'm assuming they have it the same way. Yep, and that's exactly, oh, they did it my way too? Oh, so there's one way, there's drawing it out. I wouldn't write them all out. That takes a while. Let's keep trucking. So which is more? I remember these being kind of tough. So in art class, students are mixing blue and red paint to make purple. Janelle's mixes 6 cups. Oh, here's our girl Janelle. She mixed 6 cups of blue and 5 cups of red. Then we got our boy Aiden, who mixes 6 cups of blue and 5 cups of red. Whose is more purpley? Oh, which one will be redder? Well, they have the same amount of red. So guess what? They're equally red. That was an easy one. Oh, that's because it was level 1. Ta-da! Equal quantities in both. All right, let's do a harder one. Yeah, level 2. Let's step it up. All right, students are making lemonade mix. So we got our girl Madeline. 4 cups of water. 3 teaspoons of powdered lemon mix. And we got our boy Grayson with 7 cups of water and 6 teaspoons of powdered lemon mix. Whose mix will be more watery? We want to know which one has more water, but we have to see the rate. So basically, this is 4 out of the total. So it's 4 watery, 4 plus 3 is 7. And I think this is 7 watery, and 7 plus 6 is 13. Which is the bigger fraction? We can divide them if we want. Right? We can divide them if we want. That's a choice. We've got all these choices. Let's do division. Because we just did division before. We got 4 divided by 7. That is 0.57. Let's see the other one. 7 divided by 13. The hardest part for all these problems is can you set them up? And this is 0.53. So guess what? Who's more watery? I'm going Madeline. I think Madeline's more watery. Let's see if I did that right. We got it. We got it. What? Ooh. That's wild. 1, 2, 3, 4, 5, 6. 1, 2, 3. Oh, their way is way easier. Okay, so the way that they did it, it's very similar. They said because this is a 3 and this is a 6, this is like a scale factor of 2. We can just multiply it by 2. 3 times 2 is 6. So we could make 8 watery, 6 teaspoons, 7 watery, and 6 teaspoons. So either way, we know it's a little bit more watery, and that's what we got over here. I really like that way. Much better than my method. Now let's visualize. Ooh, that's cool. There are 48 apples and 16 bananas. Fill out the possible ratios of the apples and bananas. Okay, we can divide it by 2. So that's 24 apples and 6 bananas. What? That's cool. There we can divide again. There are 12 apples for every 4 bananas. I'm just dividing it by 2 every time because they're always even. Let's go again. We can do 6 and 2. And then finally, the right answer is what? 3 to 1 is the ratio. You can't get simpler than that. If you wanted to, you could have divided this by 16 and this by 16 in the first step, but I wanted to show them all. What a cool animation. Ta-da! We got them all. All right, let's do some of these double number lines. I only added some double number lines because I think they're really useful. So one car has 4 wheels. Okay, and the other car has 4 wheels. Oh, we just have to fill out this. Okay, so this is 1, 2, 3, 4, 5, 6, 7. So 1 is 4, 2 is 8, 3 is 12, 4 is 16, 5 is 20. We got to put 4 more, so that's got to be 24. I think it's just a really easy way for a student to see every piece of it with this double number line. All right, let's go the other way, scaling up and down. So 1 egg for every 5 cups of flour. Well, we did 11. So 1 times 11 is 11. So 5 times 11 is 55. Ta-da! So there it is, times 11 times 11. Beautiful. All right, let's go level 2. Let's make this tougher. Ooh, so we don't have any numbers here. So there are 12 donuts in a dozen. So 12 donuts gives me 1 dozen. How many are an 8 dozen? Okay, so basically, if there's an 8 here, so this is the way that the double number line is working is 1 times 8 is 8. So we have to do 12 times 8 to get the other one. That's it. 8 times 2 is 16, carry the 1. We got 96 donuts. I am hungry. Magic. Beautiful. All right, I think there's one harder one, right? Yeah, level 3. Let's see what we got for a level 3 problem. All right, so Autumn has a mangoes, apricots and mangoes, 72 to 11. Okay, so we got 72 of these guys for 11. And what happens if she has 22? So we're just doubling it. So this is 148 or 72 times 2. I thought it was going to be harder because it was level 3. I guess because the numbers are bigger. There's not much more we could do. Oh, I messed it up. 72 times 2. Oh, I multiplied it wrong. Oh, all right. That's what I get for doing it in my head. All right, so we've got plantains to bananas. Plantains is first, so that's the 9. And bananas is 40. Cool. What happens if she has 90? So we're just multiplying it by 10. So this is going to be 400. Magic. Cool. All right. So let's do some finding unit rates. Dalvin read 10 books in 8 months. 10 books in 8 months. What was his rate of reading books per month? Okay. I don't know what they mean to resize. Oh, we have to drag it down. Oh, that's cool. So we have 10 to 8. So 10 divided by 2, I believe that's 5 to 4. Nice. But we want per 1 month? Okay, so let's drag it down. 1 book in 4/5. So, oh, but we want it per month. There it is. So I just had to switch it up a little bit to make it 1 month and 5/4. What a cool graphically designed thing. So if we have 10 over 8, this is the way I would do it, equals 1 over x. Because this is my books and this is my months. I just have to make it consistent. So we want the book for 1 month. So it doesn't matter how you set it up as long as you're consistent to make one of these. 10 times 1 is 10. Oh, sorry, I forgot my little butterfly. And then we have 8x divided by 8. And then all we do is simplify by dividing by 2. And that's how you get the 5/4. But this graphic one is awesome. Sweet. All right, so let's go reasoning down. Oh, now we go backwards. So Harper drove 152 miles in 4 hours. If she drove at a constant rate, how far did she travel in what 1 hour? So all we have to do is do another one of these, or we can just see it dividing by 4. 4 divided by 4 is 1. So 4, oh, sorry about that. 4 goes into, oh, I like this pen way better. I'm already way happier I did that. So 4 goes into 15 3 times, that's 12. 4 goes into 32 8 times, so it's 38. I'm glad I was able to change that line weight, 38 miles an hour. She's driving like I do, super slow. What? I got the 38. Yeah, 38 miles. I got the same thing. Oh, because I put them in the wrong order? Whatever, I got the right answer. Jackson's car used 16 gallons to go 432 miles. How many can it go in one? So we're just gonna do the same thing. We're gonna put gallons over miles, 16 over 432, and we want how many, we go 1 gallon for X. So we divide by 16. Because it's so simple, you don't have to cross multiply. It's just basically 16 into 432. 16 goes into this twice. 16 times 2 is 36. And this is going to be 72. I believe 16 times 4 is 72. No, 16 times 3? No. All right, I'm using the calculator. I had a moment. We all have them, right? 432 divided by 16. 7. Oh, so annoying. There we go. Because they didn't have me make the little chart. I guess I just made the chart backwards. All right, let's keep going. Let's match the table to the context. We got a girl, Layla. She earned $70.50 for 3 hours of work. Which table makes sense? So basically, we just have to figure out how much it is per hour. So if it's 3 hours of work, you make $70.50. We want 1 hour work. So you can cross multiply if you want. 3x equals 70.50. But either way, we're just going to divide this by 3. We have to leave the decimal if it's already there. 3 goes into 7 2 times. So 3 times 2 is 6. 3 goes into 10 3 times. So that's 9. So that's 15. $23.50. This is off. So C's out. B's out. This one's out too. So it's A. So $23.50 makes it 94. Yeah, it's A. Magic. Ooh, wow. They did so much more math than me. Feel free to use the chart. See what they did. All right, let's do some proportions. I'm excited. So it cost Michaela $5.90. So that's the cost to send how many texts? 59 text messages. How much would it cost to send 55? Just going to put the x here, cross multiply. 59x equals 55. 55 times $5.90. We could do all this math. I've shown you how to multiply with decimals a million times, so might as well just put it in. So it's 50. So I always do it in one step. Then we divide it by 59. This is how we're just left with the x. Basically 55 times $5.90 divided by 59. This is the way I've always done it. 55 times $5.90 divided by 59, and we're already done. It's $5.50 a text message. That sounds way too expensive. I already don't like the problem. We did it. Wow, that's way crazy. Yeah, that's the way I did it. I did the second method. All right. So here we go. Changing some units. Pounds to ounces. Remember, for all this change, I know I showed you conversions before. It's always what you want over what you have or what you got. So there's 305 calories in 5 ounces of ice cream. How many calories are there in 2 pounds? Before you try that problem, answer the question below. How many ounces will you need to find the number of calories for? What? How many ounces will you need to find the number of calories? I would not do it this way, but let's try it. In 2 pounds. Let's just see what 5 is. Convert pounds to ounces. Okay. All right, so we have 2 pounds. This is the way they want us to do it. So we have 2 pounds. We want it in ounces. So this is the want versus have. So we have 2 pounds, but we want it in ounces. So what do we want? There's 16 ounces. That's what goes on top. What goes on the bottom? 1 pound. It's LB. Why is LB a pound? I have no idea. So this, the top and bottom cancels. So it's just 2 times 16. It's 32 ounces. That's what they want you to do. I was going to go the other way, but that's fine. How many calories are in there in 32 ounces? Well, there's 305 calories in 5 ounces. Calories, ounces. So 305 calories in 305 calories in 5 ounces. Well, we want 32 ounces. And there's our X. Calories, ounces, then you just cross multiply. The hardest part is always going to be setting these up. So it's 5x equals 305 times 32. And we just divide it by 5, and we're left with our answer. 305 times 32. Oh, plus 0. I don't know why. Divided by 5. So I put that little plus in there. 9,760. Oh man, don't eat the ice cream. I don't care how good it tastes. I'm kidding. Eat as much ice cream as you want. Is that what? All right, so we have the 32 ounces. So 305 calories, 61. They said we had to divide it first. All right, this was my method. 305 times 32 is 5 times x. 976. Oh, I didn't divide it by 5. Because I put that mistake in there. 32 times 305 divided by 5. There it is, 1952. All right, I might as well just do one more since I got it wrong. All right. Bashir, our boy Bashir bought strawberries for 11.20. 1 pound is 16 ounces, but he bought 2 pounds. So the best way to do it is we can just multiply it by 2, but this is it. If you have 2 pounds, in case you have to go the other way, it's whatever you want. So 16 ounces over what? 1 pound. These cancel, the pounds cancel, and you're left with 32 ounces. Sweet. And now we want, what is the price of strawberries in dollars per ounce? We want 1 ounce. Okay, he bought 2 pounds for this. All right, so basically, what did our boy Bashir do? So we want ounces and money. So Bashir bought, the money was 11.20. See, I'm going the other way, and we got 32 ounces, and this equals, we just want 1 ounce per 1 ounce, and we want to know how much that costs. Cross multiply. So it's 11.20 equals 32 times x divided by 32. And that's going to give us our answer. $0.35 per ounce. We did it. Oh, they don't even have my method? That's annoying. All right, there's 3 to go. Well, like 4 to go. Our girl Maisha was driving down a road after 4 hours. She traveled 64 miles. At this speed, how many hours would it take her to go 128 miles? All right, we can multiply by I believe it's by 2. Yeah. 64 times 2 is 128. 4 times 2 is 8. Wow. Cool. I like the table. Really fun. You could always use this method, but if you have a table, it'll be helpful. All right, now we've got plotting. Nice. We got a graph here. Sweet. So she rode 384 miles in 10 hours. So we got to fill it out. So 384 is 10. I believe this is going to be 5 because this is it. So this is half. Then we have to double it. So this is going to be 8. Then this is going to be 6. Carry the 1, 768. I think that's what we got. Oh, I got to plot the points. So the number of hours is, the first one's going to be 5. Somewhere over here. And we've got 10. The 10 one is going to be at 384. Somewhere over here. And then we got 15. I'll grab this guy. Wait, I gotta move this guy. What? I gotta move this one. It's not gonna let me move the point. Well, I have to hit submit. The other point isn't there. I know. 5, 10, 15, 192, 384, 576. Oh, I got the last one wrong when I added it. All right. Well, I might as well try another one. All right, let's try another one. All right, let's see what we got here. We drove 189 in 9 hours. So we divided this by 9. So I'll actually write it out. So 189 divided by 9 will give us this one because 9 divided by 9 is 1. So that's 2, 3. So it's 23 miles for the first one. And then to get here. So this one is 1 hour, we went 23 miles. Now we have to figure out the difference here, but I'm just going to go this way. 63 over 189 equals x over 9. 189x equals 9 times 63 divided by 189. Clear. 9 times 63 divided by 189. 3. Sweet. So I can't touch it, otherwise it'll mess me up. So the first one is 123. There you go, friend. Next one is 3 and 63. There you go, friend. And the last one is 9. Whoa. And 189. Where are you, friend? 9 and 189 right over there. All right, let's see how well I did. Yeah, let's try it. What? 20. That's what I got. What's wrong with mine? 23, 63, 189. Oh, it's divided. Oh, it's 21. Oh, this 9 goes into 9 one time. Oh, man. That's another stupid mistake. 2 tries, 2 stupid mistakes. One last time, no matter how bad I mess it up. All right, so 2 to 12. All right, so we have 2 to 12. So this is times 12 divided by 2 is 6. 2 divided by 2 is 1. So here's the other one. 2 over 5 equals 12 over x. 5 times 12 is 60 equals 2x divided by 2 is going to be 30 equals x. That time, I don't think I messed it up. So here's the first one is 1, 6. I'm glad they fall in the points. Next one is 2, 12. And our final one is 5 all the way up to 30. They say this one's wrong. I might freak out. Okay, cool. I didn't make any stupid mistakes and my graph looks good. Really take your time and do those well. Okay, so why'd I put a couple of these at the end? I just gave you a couple hard ones just for the fun of it, just to like, well, not to like make you struggle, but just because like sometimes you're going to see hard stuff and you should be able to help your students. So here's a real problem. -5/9 over -5/6 minus 4/9. I know this seems really crazy. I'm going to do this piece first and then do my subtraction. So the first time I'm going to do is -5/9 multiplied by the reciprocal. So I'm going to multiply it by 6 over -5. A negative times a negative is a positive. And a top and bottom, we can think about it as 30 over 45, but they're both 5. They cancel. We're left with 6 over 9. And I'm going to leave it as 6 over 9. Why? I can simplify here, but this is the same thing. So it's 6 over 9 minus 4 over 9. 6 minus 4 is 2/9 is your final answer. If I were to simplify this to become 3, 2/3, right? I would have to bring it back up to do my subtraction. So there's your answer, 2 divided by 9. Magic. Oh, mine looks the same. No, they did more steps than me. We're not doing more steps. We're doing it quick. Oh, let's try a harder version of that. Cool. Okay, this one's really tough. So we have 7 divided by 20 divided by a negative 0.45. Everything about this problem's hard. But because I have a fraction here, my first move is let's make that guy a fraction. So 7 over 20 divided by what? Well, this is the tens place. This is the hundredths place. So this is really what? 45 over 100. Now I could work with 45 over 100, but it's so big. This ends in 5, this ends in 0. Let's divide them by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. So it's really 7 20s divided by 9 20s. Here is where it gets super easy. So we're going to change this to multiplication and I'm going to flip this. So it's really going to be 7 over 20 times 20 over 9. A top and a bottom match. Ready? Boom. Your answer is 7/9. I lost my negative sign, so a positive divided by negative is a negative. So there's your negative 7/9 is your answer. Sure, there's going to be a million steps they did. Oh no, they did less steps than me. I like it. But they didn't simplify by crossing those out. All right, let's do one more, even more challenging, and then we're at the end. All right, first of all, you never got to do 5 of them. Just do one of them. Do more if you get it wrong. All right. Oh. This one looks really crazy. So here it is. 8 3/4 minus a minus 7 1/2 divided by a negative 1.25. Now notice these are in parentheses, so I got to do it first, and 2 minuses make a plus. I'm going to turn these into mixed numbers first. 8 times 4 is 32. 32 plus 3 is 35/4. 7 times 2 is 14. 14 plus 1, this is 15/2. This is a 4 on the bottom. So I'm going to double this. So it's 35/4 plus 30/4. Remember, for adding, you add the tops. That's 65/4. Keep the bottoms. Add the tops, keep the bottoms. So it's 65/4 divided by negative 1.25. Right away, I'm going to make this into a fraction. That's tenths, that's hundredths. So it's 1 and 25 over 100, or 1 and 1/4. Why is quarter good? Because this one's in quarters. So it's 1 and 1/4. I'm multiplying the bottom, adding the top. So it's really 65/4 divided by 5/4. The last step is we're going to change that to multiply. And we're going to flip it. So we're left with 65 over 4 times what? 4 over 5. These cancel. 65 divided by 5 is our final answer, but they want this. Oh, it's going to be a whole number. How many times does 5 go into 65 once? How many times does 5 go into 15 3 times? Your final answer, I forgot my negative sign. It's negative 13. That was a lot. What? That's it, negative 13. That's what I got. My solution says negative 13. All right, well, I don't know what they wanted, but that's negative 13 and they got negative 13. So either way, we're good. I'm not even going to listen to it. All right, so here's your last one. Let me just make it, you only have to do one of them. Actually, no, you're going to have to do 3 of these because these are great. These are really challenging. I love these problems. So how much? A is a percentage of B. I think this is 45%. little less than half. 44. Oh, so close. Let's do another one. I'm going 56%, a little more than half. Exactly half? Come on. All right, let's do another one. All right, so this is 20%, 40%, 60%. I'm going 20%. It's really good to really show your students how to estimate. 17, nice. Let's do one more. I'm going 72%. That's what it looks like to me. 76. So really try those, work on your estimation. I think it's really useful. So this was your proportion and ratios. So exciting, right? I hope you learned a lot. I know it wasn't like the most exciting one, not the longest one, but I hope you got a lot out of it.